So light gives us the sensation of the things object. Okay, and when we have to see the laws of reflection, that time we are getting one thing. So one plane is there. Last year we have seen already, like this plane was there. You have seen. So some have you seen like this structure last year? Yes or no? Still, same. But which part present in the water, that part is become the thicker. Means we saw that. Actually, it's not like this. And one more thing, from this and here in the water portion, whatever the pencil is present, that is feeling like that is broken. And this happened due to the only one phenomena. That phenomena is the refraction of light. And why this happen? Because light changes direction when going from one transparent medium to the another transparent medium. Okay, if that medium is not transparent, then we can't see this phenomenon. When medium is transparent, then only we can observe this phenomenon. Okay, now keep a 5 rupee coin in a metallic vessel. You can do this experiment too. Okay, only one minute experiment you can do. So what? Take one metallic vessel like this. Your vessel, you know, at a home. Plate vessel means here they speaking about a plate or like this. Okay, then keep a 5 rupees coin here in the vessel and slowly go away from it. When we'll go away from this place to like this. So stop at place when the coin disappears. We have to stop. Some distance will go. Then we'll feel that we are unable to see the coin. And we have to look towards the direction of coin only. And tell to your friends. Now friends are not with you. Then you can tell your family member, anyone. Fill the water in vessel. Then what will happen there? Again, you'll be able to see that. Why this happen? Because when you are kept in the vessel, that time it was not transparent medium. But when you added water in that, or you put water in that vessel, that time it's their transparent medium. Okay, so due to that reason this happen, and this is our refraction of light. This light can change the direction when it going from one transparent medium to the another transparent medium. It's the refraction of light. Understood, everyone? Yes or no?
Yes, sir. Yes, sir.
A class lab on a blank paper. Now, when our regular school will be reopened, that time I'll show you, or if it's possible, I'll show you one experiment on it. Okay. So blank paper and draw its outline like this. We have to take one this glass slab on one blank paper. Okay, and we have to draw its outline. Then afterwards, give the name to it PQR. Okay, and draw an inclined straight line side PQ. We have to draw here one inclined line. This is your line. Okay, PQ at L. So pierce two pins vertically at the 2 points A and B along the line. What do we have to do? We have to put here two pins A and B. And look at the pins A and B from the opposite side of the slab and pierce pins C and D vertically so that the images of the A and B are live with CD. One students I will show directly one experiment. I think I am having it. Okay. This is one experiment for us. Okay, it's a refraction through prism. Okay, we'll see it. It's not with a slab, but with prism given here. You can watch it.
Hello scientific people. Today we are going to study the refraction experiment from the prism, and we are also going to measure the angle of deviation from the prism. And
Are you able to see this video and able to listen?
Yes,
Yes,
sir.
Okay, see.
yes, sir.
Okay.
for this experiment you require a prism. Here we are using typically a prism whose angle of prism is 60-degree, equilateral prism, and protector, scale, few softboard pins, eraser, and pencil. So let's begin with the experiment, and this experiment will be almost the same as the refraction through glass slab experiment. So what we need to do is, first of all, take two softboard pins and fix it on the wooden pad. So this is A4 size paper on the wooden pad, and now I am fixing both the softboard pins over here on two edges so that my paper, A4 size paper, does not move. Now these softboard pins, put it aside, the all rest four softboard pins you would be requiring. Now what am I going to do is, I'm going to put this prism over here, and then I'm going to mark the outlines. Okay, so here we have made the outline. Pardon me. Now we are going to make an incident ray, and the incident ray, say for example, I wish to make the angle of incidence is 60-degree. I choose this point to be the point of incidence. So this part of the protector, I need to put it over here. Angle of incidence 60-degree. So we know that the normal would be 90-degree. So this is 90-degree. So 10, 20, 30, 40, 50, 60. So the 60-degree would be over here. We are not measuring the angle from here, otherwise it would be 30-degree. We are measuring the angle from 90-degree to 30-degree. That's why it is 60-degree. Mark a point on 90-degree as well. Now, this would be your normal, and this would be the angle of incidence, right? Okay. Now, two pins, you are supposed to fix it over here on the incident ray. Now put the prism back over here at its marked position. Now you are supposed to see these two pins from this side. They will be visible to you. And now I'll be seeing the pin, these two pins from this side, because this is the incident ray, that would be the refracted ray, and the emergent ray would be somewhere over here. So I need to see the pins from here. And you need to see it very carefully with one eye closed to avoid the parallax error. So let me do it. And afterwards, what you are going to do is, when you see these two pins over here, we have another two pins which we are going to put it on this side, and we'll make sure that these two pins are in straight line arrangement with these two pins. So okay, so now these two pins when I was looking at these two pins from this side, because this is the emergent ray which is coming to my eye, so I would be seeing these two pins in this line, and now these two pins I have attached in such a way that all these four pins are visible in a straight line. Let's see it. So if you watch, if you watch these two pins, these two green colored pins are visible over here, right? And now if you see that all four pins are appearing in a straight line. You guys are lucky because you can see the spectrum band of 7 colors at the back side. So you can see very carefully all four pins are placed in a straight line, and quite spectrum is visible on the top part. You can see that there is a spectrum, so dispersion is also seen over here, right? Okay. Now what we are going to do is, now we are going to mark these two places. So I'm going to remove these pins. Now we'll put the prism aside. Now no need of these pins also. These two points join with the straight line over here. This will be your emergent ray, and from here the normal is at an angle of 90 degree. So this will be the angle of emergence, this is the angle of incidence. Now I'm going to join these 2 points, and this would be my refracted ray. Incident ray, refracted ray. Now you can see that it is, instead of going straight, it is bending towards normal due to the refraction. Now our main task is to find the angle of deviation. We know that this angle is 60 degree, right, angle of prism. Now I'm going to extend the incident ray forward, and I'm going to extend the emergent ray backwards. So I get this angle, that is called angle of deviation. So let's measure with the help of a protractor. Okay, how do you measure this? See, make sure that this point is falling over here, so like this, and the angle of deviation, this line matching with this line, and the angle of deviation is just over 40 degrees. It is approximately 42 degrees. So the angle of deviation for the prism is 42 degrees, right? And I kept the angle of incidence as 60 degree. If you just want to measure the angle of incidence, I had kept it 60 degree. So when I kept this angle 60 degree, I got the angle of deviation is this. Let me measure the angle of emergence as well. So angle of emergence with respect to the normal, 10 degree, 20 degree, 30 degree, 40 degree. You can see that from here 90 degree, this is 10, 20, 30. Now I'm mistaken, it is, yeah, it is the same only, 40. No, 35, sorry, because this is, these are the gap of 5. So this angle is 35 degree.
Okay, students, got it?
Yes.
Okay, so now we are speaking.
Yes, sir.
Now instead of keeping the prism, it's this is experiment for our regular exam, board exam or such practical exam. It's very important experiment. I will perform afterwards. Okay, if it's possible. When you come physical, that time I'll show. Definitely it's necessary there. So first, refraction occurs when light rays enters a glass at point N. Where is the reflection? There is lighting. Okay, and on PQ, where is it? Or PQ. The second refraction, where the second refraction will get here at point M. Point M, because it changes here with its medium. See this, A to B, and then here at point N, it changes at medium. So that is, it will go like this, it will bend. And again here we will get the this reflection. Okay, so at point yes sir. For the first refraction of angle, incidence is I. First is angle, I is here. And second, what is there you see? Angle of incidence, here angle of refraction. Okay, then when we measure this, I and R will get the both same. Okay, so note that I1 is equal to R. In the second refraction, the angle of refraction is E, which is equal to I. This angle of emergence. This is angle of emergence is equal to angle of incidence on the both parallel sides of PQ. Where will get these both at the parallel sides of PQ? Which is the parallel side? PQ's parallel side? Yes, sir. Or RS. Okay. And here, what noticeable thing is there? Light changes its direction. See, here straight line and here it's little. Getting it? Yes or no? What I am speaking, are you getting it, students?
Yes, sir.
Okay.
Yes, sir.
So light ray MD, which this light ray MD is the emerging from the glass slab is parallel to the incident AN. This is parallel to this. When we'll increase this, we'll get it parallel. See, it's not looking now. When we'll draw with the help of scale, we'll get it parallel. Okay. So like this, by rectangular slab, we'll get this glass slab. We'll get this experiment, and through it we can understand angle of incidence is equal to angle of emergence, and light refract from one medium to the another medium. Okay, understood everyone? Yes or no?
Yes, sir.
Yes.
समजतंय की सगळ्यांना? एक सिंपल गोष्ट लक्षात
Yes, sir.
ठेवायची. इथं काय होतंय, जर ग्लास स्लॅब घेतला आपण आणि त्याच्या साह्याने जर पिन्सच्या साह्याने जर ऑब्झर्व केलं, तर आपल्याला काय लक्षात येतं की ही जी इन्सिडेंट रे, जो लाईट रे इन्सिडेंट, तो ज्यावेळेस हा ग्लास स्लॅबवरून पास होतो त्यावेळेस त्याची काय होते, डायरेक्शन चेंज होते. आणि डायरेक्शन चेंज झाल्यानंतर तो कुठे येतो, इकडे येतो. ओके, आणि पुन्हा तो या ग्लास स्लॅबच्या सेकंड पॉईंटला आला इथं, तर तो पुन्हा काय होतो, पुन्हा रिफ्रॅक्ट होतो, पुन्हा तो त्याचं मीडियम चेंज करतो आणि पुन्हा तिथं आपला अँगल ऑफ इमर्जन्स भेटतो. आणि हा अँगल ऑफ इमर्जन्स आणि अँगल ऑफ इन्सिडन्स दोन्ही काय असतात, सारखे असतात. समजलं? यस और नो?
Yes, sir.
So now we'll see some questions are given for you. Yes, anybody having doubt?